Hello class, this is a video tutorial on direct proportion and inverse proportion. This is a second part to a two-part series, and in this video we're going to continue identifying from graphs whether they are either inverse or direct proportional. So let's take a look at this following scenario. Here we have, a cyclist is to travel 40 kilometers. So that is a fixed amount, and think of it just like as a track that they have to race. So let's graph the relationship between the cyclist's speed and the time it will take to travel 40 kilometers. I'm going to measure that in hours. I've went ahead and finished off this graph here. So before we continue, let's make some sense out of this graph. Okay, so here we have the speed of the cyclist. So here we have when the cyclist travels at 10 kilometers per hour, it'll take the cyclist 4 hours to complete. And at 20 kilometers per hour, it'll take 2 hours to complete, and so on it goes. Now, to make sense of how I got these numbers here is that this is the first value that makes the most sense, because if the cyclist is traveling 40 kilometers per hour, it'll take the cyclist 1 hour to finish 40 kilometers. Okay, so 40 kilometers per hour, how long will it take for him to finish 40 kilometers? 1 hour. So now from here we can figure out how to get the rest of these values, since we know that these are in direct proportion to each other. And we know that because if you take a look from 40 to 80, if the cyclist's speed doubles, the amount of time it'll take will halve. See, take a look. So from 40 kilometers per hour to 80 kilometers per hour, the time it's taken, it will halve, 0.5. And how I got these other values is from 40 times what number gets me to 50. Okay, the way you can think of that is 40x equals 50. 40 times something equals 50. And if you solve for that by dividing by 4, take a look. Get a calculator here. If we get 40, so 40x equals 50. So if you do 50 divided by 4, it is 1.25. So we would have multiplied by 1.25. Since it has multiplied by 1.25 here, it will have divided by 1.25. So if you do that, 1 divided by 1.25, 0.8. And I did this for all of these values here. I figured out from here, I worked out every single multiplier from 40, and I divided it over there. But that's not the point here. The point that I'm taking a look at now is once we've graphed all these points, it will have looked like this. Now, if you were to do this on a graphing calculator or in a program, it can be done much more smoothly, because that's actually what's supposed to happen. The graph of an inverse proportional relationship is a smooth curve that looks like this. It's kind of like a slope that's very steep at the beginning, like very, very steep, and then it flattens out. Now, there are a few points that we have to address here. okay, is that the first one is that this graph, if we continue graphing it, it will never intercept the x-axis or y-axis. Now, it may not look like it from here because the way I graphed it, but actually what happens is that this gets steeper and steeper, but it will never ever meet the y-axis. And you can think of that like the following. If the speed of the cyclist gets slower and slower, how much time will it take for the cyclist to finish 40 kilometers? So let's say he goes 0. Okay, let's say the cyclist goes at 0 kilometers per hour. Okay, 0 kilometers per hour. How long will it take the cyclist to finish 40 kilometers? Well, if the cyclist is stopped, so this is the speed, so the cyclist's speed is at 0, how long will it take for the cyclist to finish 40 kilometers? Well, he'll never finish because it's standing still, so hence why it'll be forever and ever. At the same time, if you take a look, if the cyclist gets faster and faster, is there such thing as 0 time? Can the cyclist go so fast that the time it takes to finish this 40 kilometer race, be 0? Is there such as a 0 time in a race? No, there isn't. So that's the main point, is that this graph, no matter how it's graphed, it should look like this. First of all, it will never intercept the x-axis or y-axis. The next one, it has a constant smooth curve. And it's not just any curve. The curve is not like this, or is it like this? The curve must always be of this curve like this. So it should always curve something like that. Okay? So it should look like that. And finally, this one's a little bit more complicated. This is called the tangent test. 1, 2, 3. The tangent test gives negative gradients always. Now, first we need to take a look at what a tangent test is. First, what a tangent is a line that touches a curve exactly once. So by that we mean, if I were to draw a line at this point here and make it touch just at that point, exactly at that point, so this point here. So if we draw a line that passes through that point, it gives me a negative gradient. And also, I'll take another example. If I take a look at this point here, and once again, if I draw a tangent at that point, just like that, so there's my point, and I draw my tangent, it gives me a negative straight line. Well, sorry, a negative gradient of that straight line. So a tangent test gives negative gradients at all points in this graph. I'll do one more just so you get the idea of it. So let's draw this point here. So let's draw a tangent at that point. So let's draw a line that touches this at exactly on its edge like that. If we take a look at that line that I just drawn, it has a negative gradient. It's going from top left to bottom right, or it's a decreasing gradient. So using these 3 points, one, the curve that goes like this, so I know I've drawn a lot on it. If the curve curves like this, that's the shape it'll make. It will never intercept the x-axis or y-axis. It has a constant smooth curve that looks like that. And the tangent test gives negative gradients always. So there's a tangent. It gives me a negative gradient. So does this one. And so does this tangent here. I hope that gives you some idea on how to firstly how to graph inverse relationships or inverse proportions, sorry, and how to identify inverse proportions from a graph. Best of luck.